you all in the same room. I know that we had all these challenges. Now I can assure you that these last X amount of weeks, was it 6 or 7 or 8? I don't remember. Will be, a little bit different, but I'm not going to saturate with everything. All right, so just here's a quick reminder. So Alex will come in and do this quiz on and off period sometime this week. Is that cool? Because I know we talked and you said it was cool. And let's see. I'm just kind of going through. Quiz not here. Kennedy will have 6th period. Okay, that works for me. Lucas. Cool, works for me. Sarah. Yeah. Okay, your choice. Dan, when we can do it?
Today, tomorrow, that's fine.
Okay, Josh, you have the test that you owe me, okay? So come on and off period. Cool? Yeah? Yeah, okay. Josh, you have a second one too, okay? Just so you're aware. And all right, we're through it. All right, friends. All right. Well, Corey, how do I know you're gonna sit there? I'll put you in the seating chart just like that. All right. So we are going. Does everyone now have one of these note sheets? These note sheets are good for this week, so please bring it back. Each day we have class, and also there will be times we will be spending, because I'm not going to saturate you. I'm not going to give you 5 lessons a week. I'm going to do a lot of the homework stuff. So in class, so if you have your books, great. If you have your phones that have the book on it because you're at Schoology on there, great. But we'll have in class time, and during our class time, you will be indeed expected to work on that that we have assigned. So we're going to start doing solving quadratic equations, which is SQE. Yay, we're so original on our naming. What is a perfect square number? What's a perfect square number? Not just an example, but an idea. What would make something a perfect square? Yeah. Okay, I like it. I like it. So 2 times 2 equals 4. So the same number goes into it multiple times, or same times. Oops, got to make this modify it. Come over. And there we go. All right. Save. There we go. Perfect. Okay. Question? No. So perfect square. So I want you to think of this. Think of the shape of square. You have 4 sides, all the exact same side, right? We learned about a square like, I don't know, elementary school at some point. So perfect square is a number that can be broken down into 2 parts that are exactly the same. So think about 0 squared. That's equal to 0. Agree? Because 0 times 0. 1 squared, 1 times 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. 11 squared? Yes. Uh-oh. We're going to keep going. 12 squared?
144.
Yes. 13 squared? 169. And then 14 squared is 196. Great job, though. All right, so that's basically the first 15 perfect squares. And how do I get it? Well, if we pick, say, 6 squared is the same thing as 6 times 6, which is 36. Okay? Pretty straightforward. Okay. If you have a phone, do you have a phone on you? Open up the calculator on your phone for me, please. I want to show you just kind of a fun thing. Ready? All right. So I want you, just on your phone, do not tell me what the answer is. I want you to do 96 squared. Don't tell me the answer, though. Am I right? How about 97 squared? Don't tell me the answer yet. 9405? Or 9409. Sorry. Yeah. So the silly game with this, how about this one? Right? You get it? So there's a little trick when it's right around 100. If it's below 100, your last two digits are how far below 100 are we? So if we pick, say, 96, we are 4 below 100. 4 squared is 16. That's my last two digits. Being that I'm below 100, I'll go 4. My original 4 below 100, I'll go 4 subtract 96 and get 92. Same thing with 97. 97 squared is 9, but I want two digits, so 09. How far below 100 am I? I'm 3 below, so I'll subtract 3 from 97 to get 94. If I'm above 100, like 102, 2 squared is 4, so I keep it as 04. And then you add the 2 above 100 to 102, so it gives it 104. Silly little trick, but sometimes amazes people that, oh my gosh, you can do that so quickly. I have a degree in math. I saw little silly tricks. All right, my friends, are we okay with how a perfect square works? Okay. Again, when you break a number down, you're going to break it down into prime components. Sometimes you might have perfect squares. Perfect squares are two of a kinds. So kind of keep that in mind, two of a kinds. So let's move on. So the square root of 36, is 36 a perfect square? Sure is. What's the square root of 36, my friends? What's the square root of 1? Square root of 0? Cool. All right. Does everyone feel comfortable with those? That's nice and fine when we have perfect squares under a square root sign. But then we have to start breaking things down. Now, we could break things down to prime components, meaning like a prime number is a number that can't be broken down any further other than be divisible by itself or 1. But sometimes you can break this down. You can say, 2 times 36 is the same thing as 72. Agree? Is there any part of that right now that is a perfect square? Yeah. So this right here is a perfect square. So I'm going to take the square root of 36, which is?
6.
Hey, what got left behind? 2. So my answer is 6 root 2 or 6 square root 2 or 6 radical 2. It's your choice how you want to do it. Now, let's say we don't know how to break it down quite as simple. We could start doing it this way. Okay, I'm going to go 2 into 72. And let's say you don't recognize that 36 is a perfect square. Then you're going to say, well, 2 times 18 is 36. 2 times 9 is 18, and 3 times 3. So if I look at this, I know that I could have rewritten 2 times 36 to be the same thing as this. Okay? So each pair makes a perfect square. So square root of 2 times 2 is 2. Square root of 3 times 3 is 3. This gets left underneath still. 2 times 3 gives me 6, so I get 6 root 2. And lo and behold, my friends, these are the same answer. So which is the right way to do it? Both. Yeah. Some people's minds work one way. You see it right away. Well, just because you see it right away doesn't mean a student that doesn't see it right away is broken. Your brains all work differently. Heck, we have a lot more people in here now than we had. And I love it. I love it. I'm so thankful. Our next big thing, big burning party of these. We'll have ice cream and a big fire. Sound good? I don't know if we really will, but I would like to think that. Can't wait to burn these masks. Okay, let me go back up. So, root 32.
16.
Ooh! 16 and 2? Now, some of you are going to see that right away. So, let's do it right this way first. 16 and 32. 2 times 16. Square root of 16 is? 4. So, I get 4 root 2. I love that answer. But some of you might need to do it this way, and this is fine. Again, friends, it doesn't mean you're broken. 2 goes into 32 16 times. All I do on a calculator is go 32 divided by 2, get 16. And then go 16 divided by 2 and get 8. And then go 8 divided by 2 and get 4. And then 2 and 2. So 2, 4, 8, 16, 32. So underneath the radical, you have this. How many of a kind make a square root? How many of a kind make a square root? 2 of a kind. So what's 2 times 2? What's the square root of 2 times 2?
4.
What's the square root of this 2 times 2? And then I still have that left behind. So then I have 4 root 2. So my friends, notice this and this are the same. Which is the right way? Whichever way your mind thinks it. Yes, sir. Yes, sir. Oh, baby. Okay, so that was a quick one, 2 root 2. Now, some of you might not see it right away. So let's think about this. 8's the same thing as 4 times 2. The square root of 4 is 2. So I get 2 root 2. Some of you might see it, I have to break it all the way down. It's 2 times 2 times 2. And how many of a kind make a perfect square? 2 of a kind. So what's the square root of 2 times 2? Well, that's 2. And then I have left behind root 2. Okay? Again, friends, which way works best for you? I'm not sure, but there's no shame in doing it the way that you're getting the right answer. And don't let a teacher tell you that the way that you're doing it is incorrect. If your answer matches the teacher's, boy, that used to drive me crazy. Here's my answer. Here's the work that does it. No, I wanted it done this way. There's a lot of different ways that we've done stuff. Okay? There's a lot of different ways to think. My friends, the beautiful thing about being us, being people, is each and every one of you brings a beautiful gift to me each and every day. Now, y'all know I have a problem with shoes, so I always make comments on cool shoes. Like, Josh, man, I like those. Don't leave those behind. I'm going to steal them, okay? I love shoes. I love people. I love what you have to bring. I love ideas. Don't let somebody tell you something is incorrect. If you're getting the right result, stand your ground. If you have a teacher that tells, if you're here still at Creek, and you have a teacher who says you're doing it the wrong way, and you try to point out your concern, and they still don't listen, grab me as your advocate. I'll come talk with you. I'll back you up. Okay? The beautiful gifts you bring are beautiful. The beautiful gifts you bring make me the teacher who I am. You all right? Cool. My friends, may I move to the next page? Okay. Let's see. Go here. All right. So now we're gonna start multiplying some radicals together. Now, there is one way that I could just say, hey, let's multiply underneath and see if we have perfect squares. And there's another way that I sometimes like to look at this. First thing I know is I'm going to make a big square root. And I'm going to break 6 down. What times what gives me 6? And don't tell me 1 times 6. Even though you're correct on that, give me some other numbers that aren't. 2 and 3? What about 10? How do I break 10 down? 2 and 5. So 2, 3, 2, and 5. 2 and 3 and 5 are prime numbers. I can't break those down any further. Agree? All right. So I'm looking for how many of a kind? So I have 2 of those. Agreed? Hey, what's the square root of 2 times 2? There's a 2 outside. Hey, friends, are 3 and 5 the same number this week? No. 3 times 5 gives me what? So 2 square root 15. 2 radical 15. Okay? Notice I didn't multiply 6 and 10 together to get 60 and start breaking that down. Now there is, some people might say, hey, let's do this. And they might start to break down root 60. That's fine. But I have found, especially in Algebra 1, if you can start breaking it down these ways and start realizing you have 2 of a kinds. So let's do the same thing with this next one. Let's break 8 down. 8 is what times what? 2 and 4. Now, my friends, I agree with 2 and 4, but can 4 be broken down further?
2 and 2.
2 and 2. And then I still have this 2 to bring down. Oh, boy. How many of a kind am I looking for a square root?
2.
So what does that give me as an answer? Outside. Just a 2. What does this give me for an answer outside?
2.
So I get 2 times 2 outside. Nothing left behind because everything came out. 2 times 2 this week is?
4.
So root 8 times root 2 gives me 4. If I had done the multiplication here, this would have given me root 16, and I'm pretty sure that root 16 is also 4. Which way do you see it? I don't know. But again, whatever way you see it is a gift. Now, my friends, if you look at root 30 and root 50, if I multiply 30 and 50 together, I get 1,500.
Break that down.
Yeah, you break it down to what? What do you want to break it down to?
Break it down to 5 over 3.
Okay, let's go with the 3. 3 times what gives me 30?
50.
3 times what?
10.
3 times 10. 10 breaks down to what?
2 and 5.
2 and 5. Does everyone agree that 3 times 2 times 5 is 30? Okay. Let's break 50 down and keep it under the same radical. The reason we're doing that is because we're multiplying them. So I'm going to break 50 down. What times what gives me 50?
5 and 10.
5 and 10. 10 breaks down to what?
5 and 2.
5 and 2. All right. How many of a kind am I looking for?
2.
2 of a kind. So I have 2 of a kind here, and I have 2 of a kind here. So if I bring 2 times 2, square root of 2 times 2, square root of 4,
25.
and square root of 5 times 5 is 25. Square root of 25 is 5. What do I have left under my radical? I have a 3 and a 5, agree? So 2 times 5 outside is 10. 3 times 5 inside is 15. So I get 10 root 15. So it's a different thought process, but I don't know if it's impossible. It's just breaking numbers down. Agree? All right. I'm going to put this. Talk to me about this. Break this down for me. Tell me. Go ahead, Philip. 5 times what? 5 times 4. And I can't break 5 down anymore, but can I break 4 down? 2 and 2. Do you agree? 2 times 2 is 4. 4 times 5 is 20. Agree? Okay, so you have 3 times 10 is 30. 10 breaks down to what? Now, some of you might have thought, well, why could I use 5 and 6? Yeah. 5 and 6 would work. Could I use 2 and 15? Yeah. But I'm breaking it down into its prime components. So now, my friends, I'm looking for how many of a kinds? So there's 2 of a kind there. There's 2 of a kind there. Is there any other 2 of a kinds up there? No. Okay, so 5 times 5 is 25. Square root of 25 is? 2 times 2 is 4. Square root of 4 is? Square root of 4 is?
4.
Square root of 4 is?
2.
2. What do I have left underneath the radical still? I have a 3 and a 2, which is a 6. So outside I have 5 times 2, which is 10. Inside I have 3 times 2, which is 6. 10 root 6. 10 square root 6. 10 radical 6. However you want to say it. 6 will not break down any further. How do we feel? Is this impossible? Have I said, hey, don't have a calculator out? No, I didn't say that. What I will tell you is, I know there's a square root key on your calculator. Please, my friends, don't be like, oh, square root of 1500 is some big old long decimal. I'm not looking for that. I'm looking for you to break it down into exact numbers. Now, an exact number, 10 root 15 or 10 root 6 or 4 or 2 root 15, they're exact numbers. Friends, let's talk about exact numbers real quick. You all live in a pretty cool time where I would say in the next few years, we are going to see us put people on Mars. To me, that's pretty darn cool. I think that's fantastic. And I don't know if you follow spaceflight at all, but the technologies that are developed with spaceflight are the reason why, Philip, hold up your cell phone, would you, real quick? Hold it high. The technology that we put a man on the moon is what developed that cell phone that you all have. So are you glad we put someone on the moon? Dude, I got a cell phone. We didn't put a person on the moon. We might not have had cell phones. We might have been still connected to the wall. Okay? What will us putting somebody to Mars? What technologies will be developed for you later in life because of that? I don't know. But I know that the science that goes with it is really cool. But an exact answer is very much needed. Because basically when we launch a rocket ship to go anywhere that we want it to go, basically that rocket ship runs out of launching fuel about 22 miles above the Earth. And it has to have built enough speed to break out of the orbit of the world. And it circles around the world, getting in a further and further out orbit. And it eventually breaks that orbit and takes that speed. Have you ever taken a ball on a string and you swing it around? And then you let that rope go further out, and it's now harder to swing. And then if you let go, that ball goes off in a tangent. That's basically what they're doing with the rocket ship. So if you could take the mathematics and make an exact answer versus a decimal approximate, your space flight will get to a certain place. If you're off by a slight fraction, that might not make that much of a difference if I'm walking from Judy to I, if I was off slightly. But if I were to walk from me to Mars, which I know I can't walk to Mars, and I was off slightly, guess what I miss? Mars. And I said you burnt all of your fuel to get to Mars, your launching fuel to get to Mars on takeoff. In fact, you've jettisoned those rockets that got you 22 miles up in the air out of the atmosphere. They have already fallen back to Earth or flown back to Earth with Elon Musk. But it's pretty cool how he's doing that stuff. But friends, the technology that comes because of space flight does improve things for us that weren't fortunate enough to go on that rocket ship. Do I want to go on the rocket ship? No, I don't really want to. I think it's cool to see and read about and watch documentaries on. I love that stuff. It's my favorite stuff. All right. I think these are my last two problems. Yes, they are. All right, so friends, I have 5 times the square root of 3 times 2 times the square root of 7. So let's multiply outside first. Does 3 break down any further? Does 7 break down any further?
No.
So this, I multiplied outside to get 10. I'm going to multiply inside to get root 21. This problem's done. Okay. Let's multiply outside. So I'm going to get negative. Ooh. I'm going to take 3, break it down. I'm going to take 75. 75 breaks down to?
25 times 3.
3 times 25. 25 breaks down to? 5 and 5?
Mm-hmm.
3 times 3 is?
9.
9. Square root of 9 is?
3.
3 is outside. 5 times 5 is 25. Square root of 25 is?
5.
Does everything come out of the radical? Yep. All right. So let's see. It's going to be a negative answer. 6 times 5 is 30. 30 times 3 is negative 90. Notice there's no square root. Why is that? Everything came out. Everything came out. All right. So my friends, as I said, we have time that we're going to start stuff in class. Okay? So this is what our assignment, which will be due next time, but we have time in class to start it. It is going to be SQE. We're skipping number 1 and we're going right to number 2. Skipping number 1 and going right to number 2. And my friends, I would like us to do 1 through 21. Now, my friends, if you do not have that page, ask your neighbor if you can come take a picture of that page on a cell phone. You can use this paper here to write down. But let's get a start of it. Questions for me? Can I stop my video now?